How do vehicle dynamics explain professional drifting? Imagine a car sliding sideways around a corner, sparks flying, tires squealing, and the driver controlling every movement with precision. That's what professional drifting looks like, but behind the scenes, it's all about vehicle dynamics. When a driver initiates a drift, they are manipulating forces that act on the car to make it slide intentionally. The key is understanding how these forces work together to keep the car controlled while it's in a state of oversteer. Oversteer happens when the rear tires lose grip before the front tires, causing the back of the car to swing outward. To control this, drivers turn the steering wheel in the opposite direction of the turn, a technique called countersteering. This helps balance the vehicle's rotation and prevents it from spinning out. During drifting, tires switch from static friction, where they grip the road tightly, to kinetic friction, where they slide. Drivers push the tires close to their limit, operating near the edge of grip, which is essential for maintaining the slide. They also use weight transfer to their advantage. When accelerating or braking suddenly, weight shifts from one side of the car to the other, reducing grip on the rear tires and helping initiate the slide. Techniques like clutch kicking or using the handbrake cause quick weight shifts, making it easier to start drifting. Yaw dynamics, which describe how fast the car rotates around its vertical axis, are also vital. During a drift, the vehicle reaches a balance point where the yaw rate, steering angle, and lateral tire forces work together to keep the slide going. The driver's steering inputs influence the yaw, which affects the side slip angle, the angle between the car's heading and its actual path. Suspension settings like camber, caster, and toe angles are adjusted to improve tire contact and responsiveness. Wide-angle steering setups help the driver control the car's movement during extreme lateral forces. Applying torque to the rear wheels causes wheelspin, reducing lateral grip and helping the car slide sideways. Managing this torque is crucial. Too much can cause loss of control, while too little might not initiate the drift. Drivers modulate throttle and brake inputs to balance the forces acting on the car. When approaching a corner, they accelerate to induce rear wheel spin, then use countersteering to control the yaw and keep the slide stable. Throughout the drift, they make small adjustments to throttle, steering, and braking to sustain the slide through the turn and exit smoothly. For engineers working on cars for drifting or developing control systems, understanding these vehicle dynamics is essential. They design systems that can manage tire forces, vehicle rotation, and driver inputs to keep the car stable even at the limits of grip. This knowledge helps create cars and systems that can perform controlled drifts, whether for racing or autonomous driving.